Hello all, welcome to my YouTube channel Embedbits&bytes. In this video, we are going to learn about Introduction to Embedded Systems. So, what are embedded systems? Embedded systems are microcontroller devices that are assigned to perform one single task. For example, a washing machine, a microwave oven, TV remote control. What do all these devices have in common? They have few buttons on their top panel, and on pressing the button, some process happens, either in the background or a process which you can visualize physically, like a motor turning on in a washing machine or a channel being changed in television. Layout of an embedded systems. First, there is an input interface. This input system can be either a panel of switch buttons or a keypad or a touch sensor or a biometric sensor. Anything that can capture the data from the outside environment. And on the right side, you can see the output devices, which are mostly LED displays or a touch screen to display the actual data. Actuators are also an output device. Actuators here refer to the relay switches, which are used to activate other devices by turning them on. Now, who is bridging the gap between the input interface and the output device? An embedded computer does it. An embedded device is a combination of both hardware and an application software. The hardware is designed in such a way to meet the needs of that particular appliance. For example, for a TV remote control, the hardware needs to be connected to the number of buttons, and once a button is pressed, it should carry the data to the television. It does not need any RAM for temporary storage. Just 16 KB or less ROM memory will be sufficient to store the program data. But in the case of a washing machine, you need RAM memory to store temporary data like the water level, delay time, spin speed, and etc. So each appliance will have a different hardware and software written on it depending on the purpose it is going to serve. Like how we speak various languages to communicate with one another, an embedded device communicates with the input and the output system via various communication protocols like RS-232, RS-485, UART, I2C, SPI. We will learn about them in detail in the forthcoming lectures. For now, get familiarized with the names. As we have known from the previous slide, an embedded device is a combination of both hardware and an application software. A hardware component which includes a microcontroller and its peripheral devices, that is input and output system. An application software to run on the top of the design hardware. This software is written dedicated to that particular hardware and it will not work across other platforms. So now, what is a microcontroller? A microcontroller is a complete and fully functioning computer on a single chip. A typical microcontroller has a CPU, RAM, ROM, peripherals, counter, timers, comparators, ADC, DC, DMA, etc. I/O ports all on the same IC chip. And there are two different types of memory. One is permanent and another is a temporary memory. Permanent memory is the ROM for the storage of the program, your C code or the application software, and RAM for the temporary storage of data. Information is carried between these components via buses. An address bus to determine which location the data should be sent or read from. Data bus to carry the actual information. And a control bus to determine its operation, meaning what it has to do with the data. Now let us see an analogy for microcontroller. Microcontroller is like a human body, where like your brain controlling the other parts of the body, there is a CPU which controls the input and the output devices, timers. Like your sensory organs, there are input interfaces which are connected to the microcontroller. Your hands and legs and the general body movements are similar to the output devices. Like the nerves coordinating the body's behavior, like receiving and transmitting all the signals, the three buses can be imagined analogous to the nervous system of the human body. I hope with this analogy there is more clarity in your understanding of the role of each component inside a microcontroller. Microcontroller and microprocessor are two terms that you often hear in embedded systems. Now that we have learned what a microcontroller is, we will now look into what a microprocessor is. Microprocessor is a VLSI chip which consists of a ALU, control unit and registers. It does not contain any memory or I/O peripherals. All these are connected via a bus. Microprocessor as in cannot perform any task. The input and the output devices are connected to the processor via three buses: address bus, data bus and control bus, which I had mentioned earlier. Microprocessor is just like the brain of the human body. It controls everything in the system, but it cannot work alone. Now let's move on to the structure of an embedded system. First, there will be some sensor to capture the information from the outside world. If you are developing a weighing machine, you need a load sensor which has stain gauge inside it. And if you are developing an automated doors opening and closing system, you need a passive infrared sensor, an electronic sensor that measures infrared light radiating from objects in its field of view. So this sensor is used in automatic door opening and closing systems. Likewise, there are numerous other sensors like temperature, pressure, proximity, radiation, position, photoelectric, which capture the data from the physical world and send it to the ADC. The data that the sensor captures are in analog form. The physical data will have infinite values between 0 to 1. But it is very difficult to perceive and cannot be understood by a microcontroller. So, these data have to be converted to a non-continuous values, where there are only quantifiable values between 0 to 1 instead of infinity. This conversion process is done by ADC. The information is fed inside the microcontroller. With the instructions in the application software, the microcontroller processes the data accordingly. If upon detecting a person, the microcontroller is being instructed to open the door, it will turn on a relay switch which powers the motor and opens the door. This is the basic structure of an embedded system. Like the Windows operating system in computer, RTOS is an OS used in microcontroller programming to perform multitasking operations. The need for RTOS is limited and is required only on systems which run on critical time-based deadlines. For example, deploying an airbag within 10 to 20 milliseconds after a crash in an automobile. And some of the common embedded programming languages are C, C++, Python, and R. So now following are the examples of embedded devices. So you can see that every gadget that's around us happens to be an embedded device. So with this, the video is coming to an end. I hope you enjoyed learning the basics. See you in the next video. Please do like, share and subscribe my video. Thank you.